So for the first problem today, we need to figure out uh, the speed of uh, the rotor with respect to the stator, and a couple of other relative velocities for this induction motor, which is operating at 60 hertz and has 8 poles, and the slip factor is given as 0.05. So let's start off with part A first. As you can see in my schematic diagram here, I've already written down some of the velocities for the stator as well as the rotor. I have color coded it in such a way that everything in black represents the stator, and everything in blue represents quantities related to the rotor. So the speed of the rotor with respect to the stator. The stator here is stationary, so it's not moving. So just the absolute speed of the rotor is what we're looking at. And we would first need to evaluate the speed of the magnetic field, and that can be given by 120 times the frequency divided by the number of poles. Plugging in the numbers, we will have something like that, finally giving us 900 RPM. And now using the slip factor, we can calculate what would be the speed of the rotor, which would be given by this formula. And again, we plug in all the numbers, and the final answer turns out to be 855 RPM. Going on to part B. Now we need to calculate what is the speed of the rotor with respect to the stator magnetic field. So now we are moving on to calculating some relative velocities. And whenever we are evaluating any relative velocity, it's kind of a subtraction of two velocity vectors. And here these are all angular velocities, but I am just drawing them linearly just for simplicity's sake in the schematic over here. So let's say if these were the two. So that is the stator's magnetic field, that is the speed of the rotor, and these are the two vectors, and here they're saying that I need to calculate the speed of the rotor with respect to the stator magnetic field. So this velocity here is the reference, and the value that we are evaluating is kind of this difference over here. So for this problem, it turns out to be n minus ns, and so we end up with 855 minus 900, which is a negative 45 RPM. The same situation for part C. Here the only thing that has changed is before that we need to discuss what the rotor magnetic field is. So the rotor magnetic field and the stator magnetic field are always the same, and keeping that in mind, the rotor field is the same as the stator field, we can draw a figure that looks something like this for this problem, where now we have the rotor field, the speed of the rotor as the reference, and the speed of the rotor magnetic field here is now represented with ns, and we can calculate the relative velocity with that expression, and we end up with a 900 minus 855. So for this case, it turns out to be positive 45 revolutions per minute. And now for the final part. So now they're asking us what would be the speed of the rotor magnetic field with respect to the stator magnetic field. As we just kind of defined that the rotor field is equal to the stator field, the relative velocity of either one of them with respect to the other would always be zero, because we are basically saying that this is what is happening. It's just two same velocities. So you can take either one of them as the reference, and eventually we will end up with an expression that looks like that, and you end up with 0.